Alrighty, welcome everybody. We'll just give you a few minutes here to get settled and then we'll get started. So the summer heat waves hitting the UK for you guys?
Seems that way. Although tomorrow it's so up and down. It might snow tomorrow. You never know in this country sometimes.
Yeah, let's not try and jinx it too much. If we can get a week of summer, that'd be great.
Don't put your jumpers away just yet.
You'll have to forgive me. There might be a backing up truck in the background. So if you hear beeping, don't worry, it's all good. There it is. We're doing some repairs on the apartment building.
No.
It's coming behind you will tell you.
Okay.
Yeah.
Yeah, we got a lift in the background. All right, great. Well, I think we're just about ready to get going here. So I just want to welcome everybody to the live Q&A about custom versus generic parts and basically what's scalable and how you can understand that as it's tied to manufacturing. So I've got with myself Nicolas from Dragon Innovation and from Farnell, Sarah, Fawcett, and Simon Wade. So why don't we start off with just brief introductions. So Sarah, do you want to kick us off here?
Yeah, thanks Andrew. So I'm from Liverpool originally, and my family and I have now settled in Leeds for the last 16 years, moving to the area to study for university originally. And my career began within supply chain management. For 8 years, I worked for two large fast-moving consumer goods businesses in Leeds. And then I moved to Farnell to manage manufacturing and demand planning for single board computing around 4 years ago. My current role is Global Program Manager for single board computers. And that means I'm accountable for the team's strategy, suppliers, and commercial performance, whilst managing various programs and initiatives and tactics to ensure we achieve our aims for the financial year. My main supplier is Raspberry Pi, who we've all heard of, and that's who Farnell are famous for. And we're one of the two licensee partners and the market leader who manufacture and distribute Raspberry Pi globally, along with all of the accessories as well. To date, we've sold around 16 million units of Raspberry Pi, and our customer base is roughly split between industrial customers, maker and hobbyist and maker pro customers, and education, direct to education. And other suppliers in our range are Microbit, Arduino, BeagleBone Black, and many others. We've got about 50 others on our line card today. So hi, thanks for having me.
Awesome, that's great. So Simon, why don't you go next?
Yep, so hi everyone, I'm Simon Wade. I'm based in Peterborough here in the UK, and I work in Leeds for Premier Farnell, where I'm a senior product manager for the single board computing range. And like Sarah, that covers Raspberry Pi, Arduino, BeagleBoard, and products, similar products. I've been in distribution now for 24 years, and previously I worked for RS Components for 10 years, managing their single board computing products. And then prior to that, Anglia Components here in the UK, where I've held both technical and product management roles. Again, managing single board computing and semiconductor products, other semiconductor products and franchises. My original degrees were in physics, and I've since got a degree in psychology. I think looking back, distribution, I kind of stumbled into distribution, but I think with both physics and psychology degrees, they both served me well within this industry.
Excellent, thank you. Well, thank you both for joining us. And then Nicolas, why don't you introduce yourself?
Yes, thank you, Andrew. So I'm Nicolas. I'm with Nicolas Avril. I'm with Dragon Innovation, and I'm based in Amsterdam. But as my name might hint, I'm actually French. My background is I'm a manufacturing engineer, but with an education as a material scientist. And along the way, as I was working in a foundry, making parts for jet engines, I followed the Lean Six Sigma Black Belt course, which led me to quality management. And then later that expanded into quality, health, safety, environment management. I've been based in the USA, in Europe, and I've worked or managed team all over the world with companies ranging from startups to Fortune 500 companies. The product I worked with, typically I've worked with super hard material in the micron size. Basically think about diamond used for honing bearing races or hip processes, to product over 4 meter long, like blades for wind turbines, to product that are more than 2 kilometer long. Think about I like to describe as a garden hose on steroid. That was a multi-layer, fully bonded reinforced pipe for the offshore oil and gas exploration. I've designed machine, I've prototyped machine, I've worked with suppliers, and I had to build factories to move a company from a garage. That garage was not in the Silicon Valley, but in the Oostergeest, for those who may know, and to make flexible carbon electrode and for full water desalination systems. 2 years ago, I joined Dragon Innovation as VP of Europe, and I'm often helping teams define their manufacturing strategies. And for the teams that are early in the game, often the question arises whether to use an off-the-shelf part as is, or to purchase a part and customize it, or to create a fully custom part. And this holds for mechanical parts, of course, but also for electronics. And my expertise there is limited, but luckily I have colleagues such as Sarah and Simon who can fill the gap.
Excellent. Well, welcome to everybody there, and welcome to everybody in our audience. So my name is Andrew Hall. I head up marketing at Dragon Innovation. So why don't I give a quick overview of Dragon, and then we'll get a quick summary of Farnell after that. So Dragon Innovation, we are a manufacturing consulting partner for companies who are building complex products and need help with the new product introduction process all the way through ongoing production. So we can help you whether you're in the early idea or proof of concept phase of the manufacturing process with our content and educational material, much like this that you're consuming right now, or when you have a working prototype, and we're there to help you scale that up to high volume manufacturing through, we have a global vetted network of manufacturing or contract manufacturers, and then also other manufacturing resources. And then when you're in an ongoing production, or whether you're going through version 2, 3, 4, et cetera, and if you're looking to optimize your supply chain, we can be there to support you as well. So why don't I turn it over to Sarah for a quick overview of Farnell.
Yeah. So just a small introduction to Farnell. We have over 80 years experience in high service distribution of electronic components, and Farnell's global businesses distributes a comprehensive portfolio of products supported by an international supply chain and inventory profile developed to anticipate and meet all different types of customer needs. And our main aim here is to serve the mass market, to provide a differentiated product technology offering with a market leading service. So you can see some of the numbers here, 900,000 customer contacts, active customer contacts. We are adding 32,000, we're servicing 32,000 additional customers per month. We have a massive global online community, Element 14, and we turn over about $1.5 billion a year. So I could go on for 10, 15 minutes, but I don't think we've got enough time, Andrew. So shall I pass you back?
Sure. I just got a couple more slides from Farnell as well, if you want to go through those quickly.
Yeah, sure. So we're the largest licensee partner of Raspberry Pi. And today we are we deem ourselves as the high service distributor of choice for current and new SBC suppliers. So that includes Raspberry Pi. And right now we're continuing to invest in a breadth of technology areas to satisfy all different types of markets and customers. But specifically alongside that, you know, we've sold 16 million Raspberry Pis to date. We have a exclusive Raspberry Pi customization partnership, which we can go into in a bit more detail. I think one of the questions is around that, which is good. We offer 24 hours a day, 5 days a week technical support and an online community like we've discussed before. In terms of the products, Pi 4 and compute module I mentioned there. Specifically on Pi 4, it's really well positioned. Right now, it's the ultimate flexible and cost-effective single-board computer to date. It's very low price point of $35 a unit, and you know, types of applications, it can be a tiny dual display desktop PC, a smart home hub, media center, a networked artificial intelligence core. It could be a factory controller and much, much more. And I think we'll go into some more different types of applications later. We stock all different types of versions of Raspberry Pi to date, and we have a diverse ecosystem of accessories as well, which enables users to build devices at home or at a professional capacity or in education and commercial uses as well.
Cool. And I think I got one more slide.
Yep, so this is just a very quick slide just talking about our customer base, which I've spoken about just then, and our current brands and product ranges that we stock today, and some of the brands coming soon to our range in the coming months.
Fantastic. Alrighty, so since this is a live Q&A and you know a lot about us, we thought it'd be interesting to know a little bit more about you and who's attending this. So I got a couple quick polls that'll ask you basically what your role is at the company. So I'll let that go for about a minute here. So it's always good for us to know who's in the audience, just so that we can help cater our answers to those specific audiences. And it's always interesting as well, just from an interesting perspective, just to see who's here. So I'll give this about another 10 or so seconds. Alrighty, great. So we got about 47% CEOs and founders, which is great. And then other is the other leading category. So why don't we do poll 2? I just want to know, are you currently working on anything? That's also an interesting aspect of the audience, just to understand if people are here just to consume educational resources, or if we're actually rolling up our sleeves and trying to tackle some problems that people are after here. So I'll give this another 10 seconds or so. Alrighty. Fantastic. So we have about 72% that are actively working on a product, which is great. So I will hop out of the polls here and we will move on. So that's great that, you know, we have people that are actually working on something. And so hopefully this is, you know, really relevant and insightful information for you all. So you can take something away from this and actually put it towards your your product. Okay, so we've had a lot of great questions come in, so we're going to try to get through as many as possible. I think we have about 45 minutes here or so. So if you have additional questions, you can leave those in the Q&A or the chat, and we'll try to answer those if we have time at the end. But just to kind of set the stage, so the majority of the focus of the questions were in regards to the generic and custom-made parts. However, there are other general manufacturing questions that have been sprinkled throughout. So we're going to try to give you more context, whether that's real-world examples or just to build off of the general questions. And of course, there was some overlap of questions, so we've taken the liberty to combine some of them to help provide a bigger answer for that. So having said all that, let's jump in here. So I think this first question it's a good one. It helps set the stage. It helps basically give us a grounding point of understanding where we're at. So I'm going to start off with you, Nicolas. So what are the limits of a generic PCB, and which is the right moment to go from generic to custom-made PCB?
Yeah, thank you, Andrew. That's a great question. The generic PCB, or a single board computer, the single board computer is available. You can get it in 24 hours. You can program it. But it's not, you did not design it yourself. So as such, one of the limits would be that the size of the board doesn't fit your product. So while a generic PCB has a form factor is what it is, when you create your own, you can make it fit. That's one aspect, the form factor. Another one is it is designed to give you a lot for the money. So you get a lot of option, and maybe you have on it a Bluetooth module, a Wi-Fi module, you have a temperature and humidity sensor, and maybe you don't need that. And we already addressed that, maybe it takes space, but it also might use energy. And if you're trying to develop, an IoT product that's going to be, carried around and not plugged into a wall, this might be one of the limits. Is you're going to be using energy for sensing, for controlling, for things you don't need. So that's, that is a limit I see, and why people would first start developing with development board, and then move to a custom PCB. And then let me touch on a third one, which is maybe a little more subtle. Is it takes some time to develop a development board, and if you are looking to use the latest chip, the latest technology that just came out, maybe you can't afford for that chip to be incorporated into a development board to test it and to then incorporate it in your design. And so if time is of the essence, in some cases you might want to skip the development board and go for a custom PCB.
Excellent. So there's kind of a part two to this. Again, like I was saying, that we had similar questions submitted, so I wanted to kind of combine this. Again, it feels like it's a good way to set the stage. So someone stated, I'm not entirely familiar with the custom versus generic parts as they pertain to a PCB, PCBA, and would like to learn more. It's my understanding that we cannot buy our PCBA for the page detection off the shelf and wire it up. We must do this. We must have this custom made, or do we? I'm interested in learning more about what's possible for a PCBA because they're expensive and the lead times are long. So Simon, why don't I hand this over to you for part two of this?
Yeah, so I think it is a bit of a misconception. certain in using an off-the-shelf solution such as the Raspberry Pi. Raspberry Pi offers users yeah, an easy route to market and route to develop a product. It's low cost and is all you need to start using and start designing on a Raspberry Pi is a USB-C power supply, a keyboard and a mouse, an HDMI cable and a screen, and away you go.
Excellent. Sarah, do you want to jump in there or anything?
Yeah, I think
add anything?
Yeah, when we saw this question, we really thought that it depends on the case in mind and the application that's being created. And I think from experience with Raspberry Pi and the types of applications, the very, very well engineered Raspberry Pi and it's very high quality board, and with such low cost, I feel like the disadvantages that you mentioned, Nicolas, are vastly outweighed with the positives, where there's lots of saving development time and cost as well. And a big thing that we spoke about was compliance cost as well. The Raspberry Pi board and other boards similar to that have compliance already completed, CE FCC compliance. It's ready to go. And often we'll design a product, people will design a product, and compliance is something that is thought of right at the end. And what Raspberry Pi have done has completed all of that, and it's ready to be designed into something.
Excellent. Well, I think that segues pretty well to our next question. I'm going to shoot this over to Nicolas. So are development boards like Arduino and Raspberry Pi only for development, or can we keep using them in a product that's being sold?
So the answer is they can be, and I will turn to Sarah and Simon on this. You can absolutely keep on using them on a product being sold. The fact that they are certified is a great help. If your product allows it, so I already mentioned the form factor. If you're making a wearable that be worn by a human on the wrist, you may not have real estate to use that. If you're making a wearable for a cow to monitor the, and it does exist, something to monitor the health of a cow, analyzing its movement and all this, you have the space. You can make something bigger. They definitely, for developing, you gain you have so much power and so many possibility, and the speed of development is a plus. But you have to keep in mind the real estate and the cost. 35 euros is not a lot, or dollars is not a lot for a powerful mini computer. But if what you need could be put onto a custom PCBA that would cost you 8 euros, you're making yourself less competitive. You have to look to develop your 8 euro PCBA. You're going to have development cost in currency, in money, but also in time. So should you bring your product faster and have a smaller margin, or are you gonna, do you have the couple of months to develop your board, and you're gonna sell so many that margin is absolutely critical. You have to weigh the pros and cons. And let me turn to Simon or Sarah on this one, because there are examples that they're aware of where the Raspberry Pi is used successfully in a product being sold.
Yeah, well, just to mention the compute module really for Raspberry Pi. So it's effectively a semi-custom assembly now. it's a smaller form factor, but it's got all of the brains of the Raspberry Pi functionality. It's the advantages of similar price point to the main Raspberry Pi 4 board. We've got the Compute Module 3 Plus out at the moment, but it's a smaller form factor. It's easy to embed into something else. So we did some research, and we've got plenty of examples that we can share with you today around Compute Module 3 Plus being embedded in the designs. We're aware of a football camera that's been used in shopping malls in Asia. We're aware of a LED controller that's been commercialized. We're aware of a compute module being designed into a product that monitors agriculture and sends data back to the headquarters of the farm to kind of monitor the various different systems we've got. Things like kiosks as well. We know compute modules been designed into the brains of the kiosk, and I'm sure Simon can go into a few more of the things that he's aware of.
Yeah, we've had success with Raspberry Pi's been designed into industrial IoT gateways for IoT applications. There's also it's a smart wall box charger for charging electric vehicles. So the Raspberry Pi is at the heart of that and provides the processing for that. And also earthquake detection. We've got Raspberry Pis into applications like that, and also digital signage. I think with the cost to entry of a Raspberry Pi, you can build a low cost digital sign and point of sale display that would cost you, the equivalent would be thousands, and you're getting all that performance for an entry price of $35. And also not to forget that the Raspberry Pi, each model, they do guarantee that it will be in production for at least 7 years. So you've got that as a benefit. You can safely design a Raspberry Pi or a compute module into an application without the worry of having to redesign that a year, 2 years down the line.
Yeah, I mean, I think those are phenomenal real world examples. I think that hopefully people can associate some of those different examples with products that they're building or working on, but that's really interesting to see. So why don't I move on for Nicolas? I got one for you. So I understand the limitations on cost and space, but can you tell me other limitations of development boards?
Yes, and let me go on limitation that maybe are perceived limitation, and so I will be talking from the maybe the side of a team developing a product, using a board, and then suddenly facing a challenge or question, and so I will expose those questions, and then I will have Simon most likely answer those. But one limitation, I mean, we talked about, it's energy, how much energy you're powering, are you powering more than what you need? But two questions that we face, those are, when you develop a product, it's very easy to connect. You plug a micro USB in there, and you have the power, and then you plug another one and you connect. And I've had the example where the team decided there's no reason to do a custom PCBA. Let's stay with this development board. It's doing everything we want. It's great. But then they started thinking, in real life, our product is going to be moving around. They were, making a robot, and there will be vibration. What if that comes loose? A USB connection is not meant to be a permanent connection. So can we, should we glue our USB connection to the board? So that's one question for you, Simon. The second one is around security. Can they be hacked? Is it easy to get in, and can someone easily hack my board and then make my product behave in an undesired way? So two questions. One on the permanent connection. Should I use a USB? Is it a limitation? Is there an alternative? I believe the answer is yes, but I'll let Simon explore. And the other on the security.
Yeah, so you're not limited to powering something like a Raspberry Pi from a USB power supply. Within the GPIO header, you can actually connect direct 5 volts direct to the 5-volt pin on the GPIO and the ground. One word of advice though, with doing that, please make sure that 5-volt supply is clean, because around the USB power supply circuit, there's thermal fuse protection and overcurrent protection there. So as long as you've got a clean 5-volt source, then yep, you can just hardwire straight into the GPIO. And also, if that's not an option, there's always you can add power over Ethernet by just attaching the power over Ethernet hatch to the Raspberry Pi. That way you can draw the power straight from the Ethernet connection. In terms of security, the Raspberry Pi is a secure product. And then again, if you are concerned about security, there are attachments from Zimbit. They've got a ZimKey product that attaches onto the Raspberry Pi that provides additional security if you are concerned about that.
Excellent. So I got another question for you, Simon and Sarah, to start. And we've kind of touched on this a little bit, but just want to get a more foundational question here. And so we feel like that we cover everything in this this part of the conversation. So is it a better idea to buy standard boards that are complete, or to make a new PCB board that are custom towards my products? So is there any other option? Feel free to kick off.
Yep. So I think there's a distinct advantage of beginning with a complete single board computer such as the Raspberry Pi. It's been designed to be embedded into an end application, and indeed the Raspberry Pi trading have the Raspberry Pi integrator program, which helps customers design the product into their design the Pi into their end product, but also supports them through the compliance process, which can save time and money. And not forgetting, Raspberry Pi have done an awful lot of the compliance work for you. So the Bluetooth and Wi-Fi module has already been pre-certified, which makes it easier to take your product to market. And again, entry-level price of $35. It's a great starting point for a project, I think, the Raspberry Pi. And then it's the decision after that. If you exceed the limitations of the Raspberry Pi, that's when I would try and move towards the compute module solution on almost a semi-custom PCB, or if the compute module is doesn't meet your needs, then go to fully custom. But again, with a fully custom PCB, you'll have to undertake all the compliance and manufacturing work yourself.
So if anybody else has anything else on that, I'm just going to move ahead. And I got one for you, Sarah. So isn't there a way to customize a development board?
Yeah, so within Farnell, we have a product customization service. and it's ideal for taking your SBC-based designs or prototypes to market. So right now, Farnell can use the Raspberry Pi technology, BeagleBone, Warp 7, or any kind of other ARM or x86 based designs. We've got an immense amount of design know-how within Farnell AVNet, and we can help you design and cost optimize products and get your products to market faster. So what customers and engineers and just tend to want is around upgrades. So they might have a Pi today, or they might have another brand SBC today, and they want to upgrade memory, they want to upgrade embedded flash, they want to upgrade wireless, they want to upgrade to wireless connectivity, different interfaces, or HMI design. They want to change PCB layout, or LTE modern inclusion. There's lots of things that we can do, and I've got a whole catalogue of services that we offer. But more specifically on the Raspberry Pi model, the customization program we have with Raspberry Pi, we've already helped hundreds of customers to date, adjusting, customizing, adding to the Pi 3 technology to make it tailored to their end goal, to their end product. And you know, it's not only within Farnell we have this service, it's across AVNet as well. We have multiple design services across AVNet, from hardware design and software and PCB design. So yeah, I think anything's possible. We would advise the customer on types of cost savings, or types of costs, or any NRE costs that might be incurred with a different type of project. And we've got a standard process that we would take these customers through. So it's been quite successful so far.
Excellent. So yeah, it seems like there's a few different ways that you customize it. Simon, did you want to jump in there?
Yeah, and just to also mention as well that Raspberry Pi, with every successive model that they've introduced, they've taken feedback from users and also looked at the applications that the Pi is being used in, and they've adapted and added functionality to the next model of Raspberry Pi. So the one big change from Raspberry Pi 3B Plus to Raspberry Pi 4 was the introduction of dual HDMI out, and that's also got 4K video, and that was at the request of Raspberry Pi users. So Pi themselves are trying to, you know, give users, you know, the latest technology to minimize the need to overly customize their application.
Well, yeah, so it sounds like that there's a few different options depending on your costs and, of course, quality and schedule. Yeah, it seems like there's a few different ways that you can go about this. Sarah, do you want to jump in there?
Yeah, sorry, Andrew.
Yep.
It was just to mention that you don't have to go down the customization route for Raspberry Pi. With the GPIO header that's on Raspberry Pi, there's a lot of accessories called hats that people can add on to add functionality. So Raspberry Pi produce their own hats. We've got a Sense hat, for example. We've got the PoE hat, and third-party suppliers also do their own hats to add functionality and add just to supplement functionality, basically. Again, there's no kind of design cost associated with that. It's actually just the purchase of the hardware. And that hat standard is compatible across all Pi models. So anything that you may design will be backwards and forwards, hopefully forwards compatible as well. Okay,
cool. I want to jump in here and shake things up a little bit, just because we got a question on production. I think that this will be a good one for Nicolas to tackle. And so basically they're wondering if they can do production domestically, whether that's US or EU, does it, since we're talking about cost here and different costing options, does it make sense economically to do that?
Yes. So the answer is yes. If your product fits the, if you let's the US or the EU ecosystem. For instance, a bad fit would be a product that you're trying to bring with high labor cost, medium volume. That would be difficult. Something that's not too big. That would it would be difficult to compete. But a better fit would be something with little labor. We're working with companies, bringing an innovative product, and on the design, they from the beginning of the development of the product, they say we do want to keep control of the final assembly. We do want to do it close to home for their own reasons, and so they've made sure that it's a couple of snaps and closing and subsystem that you can do anywhere, because whether you pay €8 an hour or €80 an hour, if the total labor component is a couple of minutes, it's not it's not incompatible. It's not a showstopper. But if you have high labor, that would obviously block you. What you have to look at, however, is not just labor, but it's also volume. So if you have a component, product that maybe has a lot of labor, but that labor can be automated, you are looking at making it in very high volume, you can benefit from automation. And whether you have an automated factory running in the Far East or in Eastern Europe or somewhere in the US, the machine is running. So that would be a good fit if such a factory exists. What would be a bad fit is, or a good fit for manufacturing domestically is if your product is quite large. I've had experience, of course, in the wind turbine industry. If you're making wind turbines, you're making factories where your customers are. So we had 15 plants, throughout the world. There were factories in the US, there were factories in India, there were factories in China. If you're making a hot tub, it can be an IoT, smart hot tub with the Raspberry Pi inside, to tell you your water quality and temperature and control all the LEDs inside, and maybe even, tell me if a Raspberry Pi can control a power board for the pumps, or if you need a hat. But yes, that's an IoT product. Basically, why would you make that, and ship that across the world? I mean, make an inflatable hot tub, or make it closer to where your customers are. So, short answer is there is manufacturing. There is manufacturing in Europe. There is manufacturing in the US. You can do injection molding. You can do assembly. You can do everything. But don't try to force. It has to be right for that ecosystem.
Excellent. Yeah, that's a great broader perspective on what we're talking about here. So kind of to dive a little bit deeper, go back a little bit more detailed oriented in producing those single units. I got a question for you, Sarah and Simon. So from a cost-effective production perspective, so cost-effective production for minimum order quantities like small batches, like single units, upon order confirmation in the first instance, how can we establish that? Sarah, if you want to take that.
Yep, we discussed this earlier, and I think it's it's going to be the case that small batches have a higher cost. It's just natural. You know, there's often one-off costs, there's NRE costs, there's minimum order quantities for components, so there might be wastage costs and excess component costs. So really, it's higher volume that you can make is definitely going to increase your cost effectiveness. To give an example around Raspberry Pi, to allow it to be so cost effective to date, we manufacture in total around 6 million units a year, and that's how we can achieve that low cost point through pure economies of scale. And the automation that's been created at the factories is another way where we can take cost out right from the start. So the board has been optimized for really low cost automated manufacturing, you know, and there's really not much more cost we can take out of Raspberry Pi today. So in answer to the question, I think small quantities are likely to just naturally increase costs, unfortunately.
So like kind of actually just to jump off on the next question, I feel like that can piggyback off of that. So part selection to minimum costs, is there a risk of those becoming obsolete? I don't know if Simon or Nicolas want to jump in.
I think there is always a risk of parts becoming obsolete, and that's again one of the benefits of using a product like the Raspberry Pi. There's established second sources for every single component on that PCB, together with a guarantee almost from Raspberry Pi themselves that they will keep that product in production for 7 years minimum. Ideally, they'd like to keep it in production for 10 years.
Excellent. So moving on, I've got, just because we've got about 15 minutes or so left, and we've got a bunch of questions left. So we'll try to get through as many of these as possible. And I know we've got a couple of questions in the chat and the Q&A. So again, if we don't get through all these, no worries. We'll follow up with you in some sort of aspect, whether that's a direct reply to you, or we can do a follow-up log or do another one of these. So don't worry, we will get to any additional questions that you all have. But yeah, in the meantime, we'll try to get through as many of these as possible. And also to state that if you go back and you want to listen to any of these answers and just get a little bit more perspective, or there will be a recording of this. So that'll be shipped around to everybody as well who signed up for this. So moving on, so the use of generic parts in extreme environments, what is boards that are rated for this, for heat, for cold, that's inherently safe for a long battery life? I'll look to Sarah and Simon to kick this off.
Simon, do you want to take this one?
Yep. So yes, yeah, the Raspberry Pi itself, it's rated at plus 85 degrees, which, yes, it's perhaps not automotive temperature specs, so in the engine, but certainly in the cockpit, using a Raspberry Pi or a compute module, plus 85 degrees is more than suitable. But you can also achieve an awful lot with effective casing solutions for something like a Raspberry Pi or a compute module. We've got Raspberry Pis, compute modules that are in a black box for ships. So it has to have effective shielding from water ingress and salt ingress.
Excellent. I know all of you can answer this next question, so I might kick it to Nicolas first and then Sarah and Simon for some follow-up. But how do you go about sourcing component manufacturers for your product? You need to secure multiple sources. I think this is a very timely question. So Nicolas, why don't you kick us off, and then Sarah and Simon can follow up.
Yeah, so what you don't want to do is go on a black market and Google online and find someone who has, some parts. You want to go to a reputable source. You want traceability, and there are, great distributors out there who have contacts with, manufacturers, suppliers. We work for Avnet. It's $19 billion a year in sales. It's a huge company. They have buying power that you can benefit from. They have field application engineers and that you can benefit from, that you can contact and ask questions, and they know what's going to be developed. So if you're trying to you're using a Bluetooth module and a Wi-Fi module, and they might know that there's a chip coming out that has both of those on the same chip, and you would save yourself some trouble. So yeah, great. There's lots of distributors out there. Find the one that you're comfortable with. If they're wearing a green T-shirt, it's even better. But it's a matter of having a good contact within one of those massive companies.
Cool. Sarah, Simon, do you have any follow-ups there?
Yeah, and just to say that purchasing components through authorized distribution, we're not in the business of selling products that are 2-3 years old. In some cases, the older the product gets, it could cause you soldering issues further down the line.
And maybe to add to this is, when you're developing your product, when you're going to go to large volume mass production, you're going to most likely partner with a contract manufacturers. That contract manufacturer, works with distributor. That's what you want to make sure. You don't have yourself to deal and to negotiate with the large, suppliers and distributors. You negotiate, have a contract with a contract manufacturer, and you specify which chip, which component you want, and they source them from there.
Yeah, but it's definitely a good question to ask in these uncertain times more than ever. Does your contract manufacturer have relationships with multiple distributors? And does my BOM have, alternative components that I could change to if needed, just from a supply chain perspective? So if we take Raspberry Pi as an example, Simon mentioned earlier that there's at least 2 alternative components for most of the BOM items for Raspberry Pi, which means as manufacturer, we can swap out any kind of component that we need to if we need to from a supply chain risk perspective. It's easy for us to be flexible and maintain the production line going.
Excellent. So kind of jumping into that process of being in production and really trying to optimize your process. I'm going to go to Nicolas for this. What are some of the best practices for scaling up and introducing automation into your production line?
So what I'm going to assume is you're going from a prototype to mass production. And the biggest change that's going to happen is the work is going to be fragmented. Whoever is going to inspect the part is not going to know, what the part is where it's going to go. So they're going to go by the specification. And if you say it needs to be this size, if it's this size, work is going to be delegated. You need to specify what is important to you, but no more than that. So, the biggest change is, the people who are going to do the work are not going to have a full visibility on the end product. And this, the second thing to keep in mind is developing a product is a huge amount of work. But once you have finalized your BOM and CAD, the manufacturing job can just start. And it is another huge undertaking. I remember having worked for a company that took years to develop a product, and they developed the machine, they made the product, and then the upper management say, okay, well, now we just need to build a factory and make more of those. And they thought it was just that. Just build it, just build more machine. When you multiply the number of things, the number of moving parts are moving, and you're increasing the volume, there's a lot going on. Don't try to do it yourself. Don't assume you can learn it all yourself. It is a whole different type of expertise. Get good partners, manufacturing partners. Dragon, we know we've worked with manufacturing partners for decades, as Dragon for over 11 years, and everyone has their expertise, and everyone has their specification or areas of expertise, and then you want to find the one that matches what you're doing.
Excellent. Simon or Sarah, do you have anything to follow up there?
I think for certainly with the experience we've had with manufacturing Raspberry Pi with Sony, who are our manufacturing partner, they have actively looked at ways of automating a lot of their processes to streamline and make their manufacturing more efficient. So we're now on to automatic packaging at the back end of the line, and they've also got Raspberry Pis that actually run the test routines to test the Pis as they come off the production line. So they've increased their capacity of number of Pis tested per minute by using the Raspberry Pi platform.
Wow.
And they've also undertaken a lot of, whereas the placement of the through-hole components was previously done by hand, that is now done by a robot. So you get a labor cost saving there, and actually more efficient flow through the production line.
This took 9 years, right?
Yes.
Right. So it's that's the amount. Once you've built you made 6 million product or 16 million, and you've been in production for 9 years, and you're on version 5 or 7. They are things you have more predictability. You can do a lot more, but nobody builds a fully automated factory with automated packaging and automation. Well, nobody. Very few for the first product.
Yeah.
Yeah, it's an evolution over the 9 years of manufacture.
Excellent. I'm going to try to squeeze one. We have a pretty juicy or big question here, but I'm going to just try to squeeze one part of that out since we're talking about factories. We got a couple minutes left here, so hopefully we can get to it. So, how to get parts that are usually available to manufacture and sold at large quantities for initial prototypes? So a super small batch. Nicolas or Sarah, do you want to kick this off, and then we'll try to wrap up here in a couple minutes.
Sorry, you want to go?
Yeah, sure. So super small batch quantities available through high service distribution. So often high service distributors like Farnell or even Avnet will have bomb quoting tools that people can upload their bill of materials, and then we would get back to you with a quote, cost and lead time. Often these components are available in very small quantities in single units rather than full reel or full trays, and being then a customer of Farnell or Avnet, you're then part of the ecosystem where if customers then move from small quantities to higher quantities, you can take advantage of the full Avnet supply chain.
Excellent. So, well, I think that'll wrap us up here. It looks like we're coming up on time, and I know we had still a handful of more questions, so it looks like maybe we'll have to run this back and do it again in the near future. So I just want to thank our panelists here. So Sarah, Nicolas, and Simon, thank you for participating and providing that expertise to the audience for some of their awesome questions, and hopefully a lot of these real world examples were helpful for a lot of people who are, you know, in that process of building a product, which I think a lot of you are who've been attending this. So once again, this has been recorded. So if you have any, you know, you missed something or you want to go back and listen to a question that was in the answer in more in depth and really focus on it, you can do that. So we'll have that, you know, probably by, you know, at least the end of the week, but if not in a day or so. So I'll send that around. If you have any additional questions for us, feel free to reach out to Dragon. We can direct it to either Farnell or answer it ourselves. So help@dragoninnovation.com is a great way to reach out to us. If you have any other questions that you don't feel were answered in this topic. And once again, thanks to everybody for participating. It's great to see what those questions are that you all are experiencing, and happy to give you perspective as to you know what's going on in the real world, and give you those real world examples. So once again, thanks everybody for participating, and we'll catch you next time.
Thanks, Andrew.
Thank you. Good
Bye,
job.
Nicolas. Bye, Simon.
Thanks, guys.
Bye.
Bye.
Bye, everyone.